Okay, everybody, let's get started. So today is exam review day. As you all hopefully know, this Friday is test number 1. So I'm going to start by going through some things that I missed. I just had a look at the key terms and looked at some things that I either missed or just treated in a cursory fashion. And then I'll throw it open for any questions, and it's kind of up to y'all how long this goes after my review of the things I missed. I will note, last class was the worst true and false test so far. I don't know, maybe y'all had a rough week. There was one question where I thought beforehand, oh, this is being too easy, this is too nice. And that was one of the worst ones, so maybe, like I said, maybe y'all had a bad week or something. But, so if you did bad, just know that you weren't alone. But okay, I wanted to start with, I'm going to go in order, but I wanted to start with this because I was a little cross with myself that I made a mistake. So I accidentally made this a plus when I first wrote it down. I fixed it in the middle of class when I noticed it, but just in case people skipped through the lecture video and didn't notice that I changed it, this is an X. So additionally, I wanted to point out that the brackets, the square brackets I have here are not strictly necessary. The version in the book doesn't have them. Because of BEDMAS, you do these two before the plus, anyways, but it may just help you to group it. But I'm not gonna give marks or take away marks if you have these or don't have these. Obviously the parentheses around E and H and things like that, those are necessary, but the square brackets are not. One thing that many of you may have noticed, but I'll point it out, it will help you memorize it if you remember that this and this are very similar. So overall the equation has this form, x over x plus y, right? So there's this, which is then repeated on the bottom, and then there's this. But y is very similar to x. The only difference is the knots, right? It's the probability of e given not h and the probability of not h. So hopefully that helps you memorize it. As I said last class, this will be one of the questions. So just reproduce Bayes' theorem, the long version. So it's only 0.5 out of 25 if you get it wrong, so it's not the end of the world, but if you memorize it, 1 free mark guaranteed. Okay. So now I'll start going through terms that I either missed or gave a cursory treatment of. So I don't think I used these terms, but I'll quickly say what they mean. For chapter 2, external world skepticism and inductive skepticism. So skepticism means you can't know. So someone who's a skeptic is someone who thinks you can't know something with certainty. So external world skepticism would be like Descartes, right? Arguing that you can't know for sure that there's an external world. Worries about the matrix and possibilities like that, those would fall under the umbrella of external world skepticism. And then inductive skepticism is what David Hume had, right? Skepticism about the possibility of justifying induction, which is generalizing from a set of particulars. In chapter 3, there was one type of inductive or non-deductive reasoning that I forgot to mention, which is abduction. Technically, it is a form of induction because the premises do not guarantee the truth of the conclusion, but it's often classified as something separate. Abduction is synonymous with inference to the best explanation. If you had to formalize it, it would look like this. Premise 1, O. So whatever you observe, whatever the data are. Premise 2, H is the best available explanation of O. So you have a number of competing explanations of O, and H, if true, would be a good explanation of O. And it would be better than the other available explanations. Conclusion, H. So obviously H does not deductively follow from the premises, but the premises are taken to be some form of support for H. Another thing I forgot to go over was the Wason selection task. How many of you know the Wason selection task? It sometimes comes up in psych classes. 1/2, 3 half hands. Okay. So there are you're supposed to imagine 4 cards, and each of them have a letter on one side and a number on the other side. So that you know. Rule number 1 is if there's a letter on one side, or just every card has a letter and a number on opposite sides. Rule 2, you don't know if it's true or not. It's a possible principle that you have to test. So this is about theory testing. And the rule is, if there's a vowel on one side, then there is an even number on the other side. So that second one, we don't know if it's true or not. And here are the cards. Okay. Does this ring additional bells for anyone? So here's the question. Which of these cards do you have to flip over to determine whether number 2 is true? So just think about that for a second. There's a certain number of cards you have to flip over to figure out whether this principle is true. If there's a vowel on one side, there's an even number on the other side. So who thinks we have to flip A over? Okay. Who thinks we have to flip M over? Who thinks we have to flip 8 over? Who thinks we have to flip 7 over? Okay, more than my intro class, but so the correct answer is A and 7. So those who got that right, congrats. However, this is a very typical class. Most people, especially if they have not been exposed to it, say A and 8. Now A is correct, and that's pretty obvious, right? So if there's a vowel on one side, there's an even number on the other side. It's like, well, there's a vowel here, you gotta flip it over and see if there's an even number. Pretty obvious. Almost no one says M. You know, what possible relevance could that have? Okay, that's right. Okay, now let's think about 8. This is what always throws people off. If we flip it over and there's a vowel, that's fine. Yeah, that's consistent with the rule. But suppose we flip it over and it's a consonant. Does that matter? And the answer is no. Because it says if there's a vowel, then there's an even number. It doesn't say if there's an even number, then there's a vowel. So 8 is irrelevant to whether the rule is true. Whereas 7 is relevant. If you flip this over and there's a vowel, then the rule is wrong. So as I say, this class gave did better than average because some of you have probably been exposed to it. So this is a very well replicated effect. And the takeaway is that what people are trying to do once they hear this principle is they're trying to confirm it. They're thinking, what would count as evidence for this principle? And that's what they look for. This is the sense of confirmation bias, or it's the sense that confirmation bias originally had as a term. Nowadays, psychologists usually use confirmation bias to mean seeking or evaluating evidence in a way that favors your beliefs. That's kind of the standard meaning. But originally, when Wason put this forward, he meant this. Not trying to confirm beliefs that you have, but just trying to confirm statements in general. That when people are evaluating statements, their default is to look for confirmation, whether they have prior beliefs about it or not. So it's more general than the sense that now the term usually has. And Popper's philosophy of science, you could see in part as being a correction to this. Right? We have the natural bias towards trying to confirm ideas or hypotheses, whereas Popper, of course, emphasizes trying to disprove ideas. And in this case, that would have led to you giving the correct answer. So that's the Wason selection task. And then one final thing from chapter 3 that I forgot to discuss is the curve fitting problem. It's trivial to prove mathematically that for any finite set of data, you can have an infinite number of different functions that run through all the data. So let's say you have two variables. Let's say it's the PCLR, so the psychopathy checklist revised. So you have people's scores on some measure of psychopathy. And what you're trying to predict is likelihood of committing a crime once you leave prison. And here are the points you get. And the obvious thing to do would be to run a line through it. But I don't know, what if it looks a little bit like this? Maybe you want to run a curve through it. Now those would be the sensible things to do. But strictly speaking, you could do all kinds of goofy things that actually wind up touching every single data point. And there's no strictly logical basis for preferring one over another. You have to bring various pragmatic considerations to bear. This is relevant to another term from chapter 10, which is underdetermination of theory by evidence. Theories will always have more implications than we can test. And any finite set of data will never be able to determine which theory is true with any kind of certainty. It's always possible to have, many of the possibilities will be kind of goofy, but you can have other theories that would explain the data equally well, and any finite set of evidence will not be able to determine which theory is right. At least that's what it means to say that theories are underdetermined by the evidence. As I mentioned, I cut a few terms from chapter 6 because they were from the older version. But two that I've left in that I still want to mention are, these are both related to Feyerabend, the principle of tenacity, and the proliferation of alternatives. The principle of tenacity just means that there is a tendency in science for people to stick to their theories even in the face of problems. Kuhn didn't use that fancy term for it, but Kuhn thinks something similar, right? That people tend to stick rigidly to their ideas, and Feyerabend thinks this is good, right? Because you want lots of different ideas to be developed as much as possible, even if they seem to have problems. This relates to the other term, proliferation of alternatives, which is that Feyerabend wants there to be lots of different research ideas developed. He doesn't want, this is where he parts with Kuhn, he doesn't want science to be rigid and dogmatic. He thinks that makes science too similar to religion. He wants science to be a free and open enterprise in which lots of different ideas are developed. And then the other term from chapter 6 that's important is linguistic framework, which is a term from Carnap. Carnap, you don't need to know his name, but he was one of the positivists. He was in the Vienna Circle. And linguistic framework is his term for something like a paradigm. He doesn't mean quite paradigm, but a framework within which statements make sense. And this is the guise under which Carnap made the point that within a paradigm, or for his term, within a linguistic framework, there are clear rules for what's true and what true and false mean, what counts as evidence for something. But if you are moving between frameworks, there are no such rules. There are no framework-independent rules for which framework to choose. There, it will be pragmatic considerations that decide the issue. Oh, and sorry, I missed one from, there's one from the Kuhn chapter that I missed. The book has a good discussion of this, so if you even took a cursory look, you would have seen this. But one thing that Kuhn emphasized that is contestable, I'm not going to say this is necessarily always as true as he said it was, but there's a standard picture of science in which it's continually progressive. All the way from the ancient Greeks to now, we keep accumulating more and more knowledge. I think it's Newton who said, if I can see far, it's because I stand on the shoulders of giants. So that's the idea that science is always progressive. Kuhn rejects this and thinks that often scientific revolutions are non-cumulative, that they destroy or undermine a lot of the theorizing that came before. I think that's quite contestable, but that's what Kuhn means by that idea. And then the only other thing I wanted to add, and this may have been obvious, but I sometimes listen to my lectures afterwards to see if I could have said anything better. So remember this example where you want to cash out what it means to say you are X% confident in something. So for example, let's use a different one. Let's say the sentence is the Oilers will win the cup. One way of making your confidence in that precise is to say which bet would you rather take. And in case this wasn't obvious, with this example I meant there's one black ball, 3 white balls. You have to choose one at random with your eyes closed, and the bet would be if you choose the black ball, then you get the money, just in case that wasn't obvious. Okay, so those are all the things I wanted to say and wanted to review. The floor is now yours. Are there any questions about anything in the course? Yes?
What was Hume's fork from chapter 2?
Good, so Hume's fork, Hume believes there are 2 ways of knowing things. This is the relations of ideas and matters of fact. So relations of ideas has to do with knowing that something is true or false purely as a matter of definition. So statements like 2 + 2 = 4, all bachelors are unmarried, things like that. And in some sense, they're not really truths about the world. They're just true about how our terms work. Whereas matters of fact, Hume thinks you can only know through observation. So everything else that you want to know about the world, you have to learn about it by looking at the world. So everything else, like metaphysical intuition or stuff like that, Hume thinks has no rational basis. Other questions? Yeah.
What's the difference between false and meaningless?
Good, so this is a distinction that the positivists make. They think there are 3 kinds of sentences: true, false, and meaningless. A false statement would be something like, there are 12 planets in the solar system. So that could have been true. It's a perfectly well-formed sentence that you can test. So both true and false sentences have to be empirically verifiable. You have to be able to test them through observation. So there are 12 planets in the solar system is false. It's perfectly meaningful, perfectly testable, it just happens to be false. A statement like God exists, for the positivist, is going to be meaningless. There's no way to empirically test it, so it's neither true nor false. If it's not testable, it's not. It's neither true nor false.
Okay.
Other questions? Yep.
Would you be able to explain the verisimilitude by Popper? Like, I don't really
Yep.
understand.
Yep, so verisimilitude. So there's two parts to it. So vera relates to, I think it's Greek, but whatever. It relates to a word for truth. So verily, verification. And similitude means similar to. So think about Isaac Newton's theory of gravity. Isaac Newton's theory of gravity is strictly speaking false. In a technical sense, if a theory has any false consequences, technically it's false. But clearly it's a better theory than the theory that little gremlins are what make electricity work. The theory that little gremlins make electricity work has no truth to it. It's just complete rubbish. But Newton's theory is a good approximation to the truth. So it has more verisimilitude, more similarity to the truth than the theory that gremlins or the moon is made of green cheese or stuff like that. So it's similarity to the truth. Now you may ask, how do we cash that out more precisely? And the answer is, attempts to do so have been a failure. Popper tried to develop a logically definable account of verisimilitude, and it didn't work. But at least conceptually, that's what it is. It's similarity to or approximation to the truth. Does that help?
A little bit. I don't know where I read it, but I think it was from the additional PDF that you provided, the conjecture and refutation. I feel like he said something about like the amount of truth, like the theory.
Yeah.
Is it a quantifiable thing?
He thought it was. Conjectures and refutation is where one of the places he first put forward an attempt. I believe the way he did it was, you would take a sentence, like a theory, and count up the number of implications, so how many logical consequences it has, and look at what percentage of them are true. For boring technical reasons, that was a failure. But there's clearly something to it, right? Because clearly, as I say, Newton's theory, even though false, has something going for it, wherein it's closer to the truth or a better approximation of the truth than other ideas. Yeah, good question.
Thank you.
Other questions? Oh, sorry, yes.
When you the term in chapter 4, all F's are G. What was that?
Oh yeah, I guess I didn't talk about that. So that's just a way of talking about scientific laws. And it's an overly simplistic way of doing it. So I mean, the classic examples that people talk about are like all swans are white. And what you want is, or what the positivists wanted, is a way to infer that that statement is more likely given a bunch of F's being G. So you find lots of GFs, you find lots of F's that are G, with lots of swans that are white, and you want it to be the case that inductively shows that the statement all F's are G is more likely, and as we saw, that failed for different logical reasons. And so what Popper says is, well, we can't do that, too bad. All we can do is say, we put forward all F's are G as a conjecture, as a guess, and if we find any F's that are not G, then we falsified the conjecture. That's all we can say. All we can say is the conjecture that all F's are G has not been falsified yet, and no further. I noticed on my notes one other thing I forgot to mention. This is not a testable thing, but it's something I wanted to highlight as one good feature of structural realism. So remember that structural realism is the view that what's real are real patterns. right? The mathematical relations that a theory posits. And I just forgot to mention that that quote that I read from Bos von Frossen, where he seems to say something pretty close to that. Just in general, when you're studying philosophy or science, when two diametrically opposed views wind up converging on something, it's probably got something going for it. So the fact that the most advanced version of realism is this, where what's real are the patterns, and the most advanced version of anti-realism, Bos von Frossen, when you press him, when you put him against the wall and say, what about the no miracles argument, what he winds up saying is, well fine, the regularities are real, which is pretty close to this, so just wanted to mention that. But anyways, other questions? Yep.
What's instrumentalism again?
Good, so Bos von Frossen is a version of instrumentalism, or at least Godfrey Smith says you can classify it that way. Instrumentalism is opposed to scientific realism. It says that the goal of science is not to discover the truth, the objective, mind-independent truth. Science is a tool or an instrument for making predictions. That's what it is. So are there really quarks? Is there really fusion inside the sun? Who cares? Our theories about those unobservable entities are just tools for making predictions. Any other questions?
So it seems to me that like the theories we've talked about at this point in time are quite old. Has there been any progress in this field that since like that we're not talking about yet?
That's a good question. I don't know how, I mean, for philosophy it feels pretty recent to me. I mean, structural realism, I think, was put forward in the 90s. And the distinction between epistemic and structural, I want to say, is more like the 2000s. Don't quote me on the exact days, but I mean, yes, there are philosophy of science journals where, you know, stuff is published, has been published in the last few years, but we've been focusing on like the big, you know, most influential stuff.
But there's been no like, say, a paradigm shift.
No, I don't think there's been. I think the most recent really cool new idea was structural realism, at least that I know of. But no, I don't think there's been a paradigm shift in the last 10, 20 years. Other questions? Yep.
Could you explain critical mass of anomalies again?
Yeah, so one of the key things Kuhn says is that there are two basic things you need for a paradigm shift. Now, there's not going to be a strict rule for when these criteria are met, but to a first approximation, this is what you need. And one is a critical mass of anomalies. So Kuhn thinks all paradigms will have anomalies, things they have difficulty explaining. And they do not, as I repeatedly emphasized, scientists do not instantly throw away a paradigm once there's a couple of anomalies. But once there is a sufficiently large number, critical mass, that is one step in getting a field to move towards a revolution. Now, exactly how many constitutes critical mass, there's no rule for that, but you need some sufficiently large number of anomalies or problems. And you need an alternative paradigm. You need both of those things for a revolution to occur. So think of, you know, Newton and Einstein, right? Newton's theory was pretty damn good, but it had some anomalies that were accumulating. But the revolution occurred once Einstein's paradigm was put forward, which explained the same things that Newton's paradigm did, plus the anomalies. Thus, there was a revolution. Okay, I see no. Oh, yes. Go ahead.
What's a cognitive revolution again?
Yeah, so the cognitive revolution is the transition from behaviorism to the cognitive perspective. And you could tell a similar story there, right? There were various anomalies in the behaviorist framework, like latent learning, for example, but behaviorism was not overthrown until the cognitive perspective was articulated. Yep.
What's the non-causal mathematical formalism?
Oh, yes. I guess I wouldn't have used that term. So there are two things that are nice, that's nice for a theory to have. One is some kind of causal mechanism. Right? If a theory or a paradigm has a causal mechanism, that's good. But sometimes a theory will not have a causal mechanism. It will just have a mathematical description of what happens. So the classic example here is Isaac Newton's theory. So gravity is conceptualized as a force that acts at a distance at an instant. How does it do it? Here's an equation for what happens, and people tried. Now with Einstein, you do have a mechanism, but Newtonians tried to find a mechanism. There was none, and Newton's view is basically, well, that's too bad. The math works, so we're going to go with this. What's interesting is Descartes had a theory of gravity that did have a causal mechanism, but its predictions were not as accurate as Newton. So that's a case where you have two paradigms, each has one advantage, and which one you choose is kind of paradigm dependent. In Newtonian mechanics, accuracy of predictions matters. In Descartes, having a mechanism matters. So that's an example that Kuhn would have liked. Okay. Any other questions?
Could you explain principle of economy?
Oh yeah, so principle of economy, I'll tell you right now, that one, I'm 99% sure it's not on the test, but it's basically the same thing as Occam's razor. So you prefer a theory that's simpler. If there are two theories that are equally good, you go with the simpler one. Kuhn tried to use this to argue for his crazy idea that the world changes when the theory changes. I think his argument using that is pretty silly, and Godfrey Smith says the same thing, but yeah, that's what that means. Although I'm pretty sure it's not on the test.
So in terms of that, I know that he didn't necessarily exist at times where we have this evidence, but we have quite significant evidence that our cognition does change as a result of experience, and things like culturally, oh my gosh, I can't remember the illusion name.
The Muller liar?
Yes, thank you. There's a cultural impact there.
Mm-hmm.
And in that way, we could say that our physical perception is changing based on
Good.
a belief system. And to a small degree, wouldn't that have some weight? I know it doesn't necessarily carry the weight that Kuhn wanted it to.
Oh yeah, the way that I think it has, I would certainly accept, and even someone like Popper, who's opposed to Kuhn, would accept. What Godfrey Smith tries to press is that the right way to, and I agree with this, the right way to say it is, and you said it this way too, our perception of the world changes, but it's not the case that the world changes. That's a line that Godfrey Smith wants to have very sharp, and Kuhn kind of muddies that by saying, no, the world changes, not just our perception of it.
So that doesn't that presume, though, an external world?
Yes, it would. I should be clear, like, even though, I guess this isn't testable, this is just if you want to know, like, my view on this. I think Descartes is right that you can't know there's an external world with certainty. The weird inference from that I wouldn't accept is, therefore we shouldn't assume that there is one. I think it's a much more fruitful assumption to think, no, there's an external world, it's there when we close our eyes. What I would reject is the idea that we should only accept ideas that we can know with certainty. If you do that, then you can accept like 5 things. You can
5? You can find 5?
Well, I mean, like, maybe 0. I mean, I think 0, but maybe that you exist, maybe that, like, mathematics is right, and, you know, logical truths, like, you know, if A then B, A, therefore B. I mean, I don't literally mean exactly 5, but, so, I think the argument you're putting forward would only work if you assume we should only believe things that we can know with certainty, which therein lies disaster, I think. But good pushback. Other questions or pushback? Or maybe a follow-up, I don't know.
Not on that, but if you say something else, I'm sure.
Okay. Okay, so I'll stick around if you want. If you're too shy to ask a question in front of everyone, you can talk to me now or during office hours. But good luck on the test. So I'll just to be clear, in case you have bad memories, the test is on Friday here during normal class time. And reminder that you have to submit 3 versions of the paper, 2 on e-class. So one, the Word document or PDF or whatever you do, the audio recording of you reading it out loud. And they may seem tedious, but I guarantee you will find mistakes. And a physical copy at the beginning of the test. So good luck with studying, and as I say, I'll stick around if you have other questions.
Do you think the midterm will take like the whole 3 hours?
Oh yeah, no, so it will almost certainly not. And in fact, if it does, that should cause you concern, because for the final, you will have basically the same amount of time. You'll have 10 minutes more. But you'll also have an in-class essay. So the midterm is 30 definition questions and 5 short answer. The final is that, plus the in-class essay, which has 5 questions that I've already put on e-class. So it should only take you like half the time-ish, give or take. If it takes you more, then study harder for the final.